Hello, Namaskar, Sat Sri Akal. So again our topic is Laws of Motion Physics 11th Unit 3. So we studied in the previous lecture about Newton's second law of motion. So the definition was uh, change of momentum, rate of change of momentum of an object is directly proportional to the external force applied on it, and the change in momentum takes place in the direction of force. And the relation we found was F is equal proportional to dp by dt, etc., and we found this relation F is equal to ma. So k was proportionality constant, which was equal to 1. So from Newton's second law of motion, we find the relation which can help us to calculate or measure the force. So the formula we derived, or actually Newton derived, F is equal to ma. So this is the formula which you studied in your previous lower classes. Force is equal to product of mass and acceleration. So force is equal to mass into acceleration, and here we consider mass to be a constant quantity. So F is equal to ma. So from this formula we find the units of this force. So obviously mass is measured in kg, acceleration is measured in meter per second square in SI. So therefore units, so we are talking about absolute units. You will come to know about absolute, why absolute. So kilogram meter per second square, so S minus 2 we write like this in SI, and is known as Newton. So why this N is blue? So this is blue because it has to be in lowercase or small n. So if you write n, then it is capital N. So this is very important. If you write Newton, complete Newton, then it should start from this lowercase n, small n, or if you write only n, then you must write capital N. So this is very important thing. So then CGS system is also there. So in CGS we measure force in dyne. So we measure force in dyne. So then there is a relation between Newton and dyne, and the relation is given by 1 Newton is equal to 10 to 5. Dyne means 10, 1 lakh dyne will become 1 Newton. 1 lakh dyne means 1 Newton. So if someone asks you the definition of Newton, then what will you say? You will say 1 Newton force, because it is in numbers, 1 Newton. So 1 Newton means 1 kg meter per second square also. So you can also write this thing. So 1 Newton would also mean this thing. So 1 kg, that is the same thing, 1 Newton, or you say 1 kg uh, meter per second square, or 1 kg ms minus 2. Force is that much force. So because we are now talking in terms of numbers, and we want to feel that number, okay, how much is that number. So 1 Newton force is that much force which produces an acceleration. So it will, when you apply a force, when you apply force, so there is acceleration. So when you apply force, there is acceleration. When there is acceleration, there is force. So therefore this relation tells you, this relation is speaking something you have to find. So this is something, a riddle, which you find the language for that riddle, not actual language. So when F is equal to ma, so that means when there is force, there is acceleration. When there is acceleration, there is force. So without force, no acceleration, and if there is acceleration, there is no force. So you must keep in mind, force means acceleration and acceleration means force. This is very important. So therefore 1 Newton force is applied, it produces 1 meter per second square acceleration in the body. Which body? That body which has a mass of 1 kg, because there is m also. So the formula says mass into acceleration. So force is applied on which body? A body which has a mass of 1 kg, and an acceleration is produced. How much acceleration is produced? 1 meter per second square acceleration is produced. So 1 meter per second square acceleration is produced in a body which has mass of 1 kg. So this is the definition of force if you want to tell in language. So otherwise mathematically you have written this thing, so its unit is this, but how much is that? For example, if I tell you something length, so I say this is 1 meter, you understand what is 1 meter. So you directly measure with your inch tape or your meter scale or whatever. You can measure and you know the feeling the measurement how to measure that. So but in case of force we do not have in our mind what is 1 Newton, how much, which force we say 1 Newton. So that is 1 kg. 1 kg you easily find 1 kg. What is 1 kg? So you might have purchased 1 kg potato, 1 kg tomato, 1 kg sugar, 1 kg tea leaves, 1 kg something else. You may have purchased 1 kg of something in your lifetime. So 1 kg you easily understand, or even if you have not purchased, your mother, your parents, they may have brought something from outside 1 kg, and you may have lifted that 1 kg, and your parents have asked you to put this 1 kg of something from this place to that place. So you know 1 kg. So now you know 1 kg, and 1 meter per second square acceleration is produced in that 1 kg. Now that acceleration you can understand that your speed is changing by 1 meter per second in 1 second. So in 1 second speed or velocity is changing by 1 meter per second in 1 second. So that is acceleration. So if you have 1 kg of something and you apply some force, and its acceleration change by 1 meter per second, so means 1 meter per second square. So then the force you applied was 1 kg meter per second square, that is 1 Newton. So this is the definition of 1 Newton. Now we can also have the dimensions. So dimensions, obviously from this formula, mass have the dimension m, acceleration has the dimensions of lt minus 2. So therefore force has the dimensions of so we can write like this: F is equal to, so for the dimensional formula you can write F is equal to mlt minus 2. So these are the dimensions for force, the units, the dimensions. Now we were talking about absolute units, absolute units. So now when you come to this gravitational units, you will come to know why these are absolute and why these are relative unit. So suppose you are carrying a bag of 10 kg of vegetable. Now suppose you go to some market and purchase, your mother or your father or yourself purchased, bought something, say 10 kg of vegetables, and you have to carry that from your the market to your house on foot. You are not having any cycle or vehicle or whatever. You have to go on foot, and you have to carry that 10 kg in your hand. So you feel tired if you have to walk by carrying this bag from market, say 2 kilometer from your home, or say 1 kilometer from your. You say it is very heavy and my arm is very much stretched or tired. So you feel that thing. So why do you feel this thing? Why do you feel tired? What is happening? So what is happening? Earth attracts the bag. The 10 kg bag is, you are carrying that bag, and Earth is attracting that bag. You know it from your previous classes that every mass is attracted by earth, and earth attracts everything by acceleration due to gravity. We say g, small g, 9.8 meter per second square. So therefore earth attracts this bag, 10 kg bag, and pulls it. Pull is always acting on the bag, so earth is always pulling the bag, always. And if you leave the bag, it will fall down. If you say I am tired, I am leaving, if you leave the bag, it will fall to the ground. So earth is attracting, therefore it will. So but from where Newton came to these laws? So we have a story that an apple fall down, and he thought, why this apple is falling down, why it is not going up. So from there these whole things started, Newton's laws, etc. So Newton's law of gravity, etc. He found that. So therefore, that is very important thing, that Earth attract things. If there is no attraction, there is no gravity, then there will be no tiredness. So you will feel no tiredness by carrying 10 kg, even 100 kg you can carry if Earth is not pulling the things. Sorry. So therefore, because of the attraction of Earth on every mass, you feel tired. You feel this is heavy. So means you will say it is very having great mass. So that thing, Earth attracts things. Now you can compare this force. When you carry this 100 kg and walk, and you can feel that 100 kg, you have in your mind. If you have a lot of practice of going to market daily and carrying 10 kg of something, or if you are not going, you may be going to some gym, etc., or weightlifting you are doing, then you understand the weight of 10 kg. So is you have to understand 1 kg, 2 kg, 5 kg, 10 kg, etc. You have a feeling in your mind that this is 10 kg. Now with practice you can tell something that this is 10 kg. If somebody asks you to lift a bag, so when you lift you say, "Oh, okay, it seems it is 10 kg." Why? Because you have the practice, you have the knowledge that this much mass may be 10 kg from practice. So if you have the feeling of 10 kg, then if someone asks you, is usually this 10 kg is I'll show you something. Say we have say, so always things are downward. So earth is always having downward. So downward. So earth always have attraction downward. Is for this 10 kg, you had to apply a force in upward direction. So you have to balance the force of earth. So you have to balance the force by earth of the earth by applying your body force. So this is the earth is attracting the body in the downward direction. If you have to carry that thing in your hand, you have to apply equal force in opposite direction. Therefore you feel tired. So you are struggling with the earth to carry that thing. So there is a struggle between you and earth to carry that thing, and earth is pulling in this direction, you are pulling in that direction, therefore you feel weight of that body. Now if suppose there is a force in, you apply a force in this direction, horizontal direction. If you apply a force in horizontal direction, if you apply a force in horizontal direction like this, then how much force here? Also you are applying some force. You had 10 kg here, you are applying equal to that force. So let us have 10 kg. Earth is having a force on 10 kg, this downward force on 10 kg. You are having a 10 kg force also, in upward force at least. 10 kg force, you are also applying 10 kg force. Earth is applying 10 kg force in downward direction. You are applying a force 10 kg in upward direction, so that you are balancing the earth force so that you can carry that bag. So this is very important to understand the concept of force, the gravitational and absolute units. So now suppose you, there is a table where you apply some force. So let us have some table. So let there be a table and you are applying some force. say the force you are applying is again 10 kg. So now how it can be 10 kg? It should be in newtons. Obviously this 10 kg is the force, but we are saying 10 kg. This 10 kg, so let us understand. So we had the formula F is equal to ma, F is equal to ma, without vectors I am writing. So force and mass into acceleration. So if mass is 10 kg, so if mass is 10 kg, 10 kg and there is acceleration, there is always acceleration, earth is always applying some force. What is that acceleration? It is 9.8 meter per second square, per second square. Earth is always applying this much of acceleration due to gravity, 9.8 meter per second square. So value of g actually. So we therefore we write mg equal to mg. So g is small g. So this g. So m into g. What is the g? Value of g is so this 9.8 meter per second square. Earth is always applying this much of force. So this is the value of this g, small g. So I think you understand this. So F is equal to ma is equal to 10 kg into 9.8 meter per second square. So therefore, if you are carrying 10 kg of weight in the downward, earth is applying a force of 10 kg, means how much? It will come out to be 98. So this will come out to be 98, equal to 98 newtons. Now 98 newtons, capital N. So it should be capital N. So 98 newtons. So 9.8 meter per second square equal to 98 newton. So this is the force earth is applying on the body. Now you can understand, when you are carrying a bag of 10 kg and you are applying upward force to balance this downward force. So you apply actually 98 newton of force. So you apply 98 newton of force in this moment. But you never talk about 98 newton. You simply say I am carrying 10 kg. And you understand this is I have to apply some force. But suppose again you apply a force on this table and say you are applying 98 newton here. So if you apply 98 newton force on this table, you can say equivalently that 10 kg force I am applying. You can say equivalently that you are applying 10 kg force. So 10 kg force you are applying. So you can say that this force, which is actually 98 newton, if you want to say force, then it should be 98 newton. But to get rid of this g, this factor 9.8 or this g, small g, you can directly say you are simply applying 10 kg force. Why? Because you understand 10 kg. You very easily know that if this much force is 10 kg, then this force is again 10 kg, because it is also 98 newton, it is also 98. Means you have found some equivalence for this vertical force and this horizontal force, or this may be oblique force, whatever, but it is not vertical. If other than vertical force is there, what you do, you will get rid of this small g or 9.8. So you divide by this 98. If you divide this 98 by 9.8, what you get? You again get 10 kg. Therefore you divide this 98 newton by 9.8. So divide by 9.8 meter per second s. So we have minus 2. So okay, so it is minus 2. So 9.8 meter per second, if you divide this 98 newton by 9.8, you will get 10 kgf. So therefore this is kilogram force. So this is how you make equivalent, by dividing this 9.8 meter per second square, etc. So therefore it is So therefore this value 10 kgf, which is actually a force, but you are telling 10 kg. 10 kg is mass, not a force. So you put a f with it, so it is force 10 kgf. That means you have to multiply this 10 kg with 9.8, so to get 98 newtons. I think it is clear now. So because of the feeling which we have by carrying vertical mass hanging in our hand, so from that feeling, when we apply a force on a table like this, we apply some force on a table like this, so we don't tell this newtons, we tell I am applying this much of force 10 kg, because I had the feeling of 10 kg, therefore I said I am applying 10 kg force. So this is how you have this gravitational unit. So gravitational unit means you simply say kilogram force or gram force in CGS. So this 9.8 meter per second square is the factor which plays an important role here. So I think it is very much clear now. So you sometimes say force or sometimes you say weight. So it depends upon the situation. So it can be weight also. So if you weight, in this case it is weight. So it is actually 10 kg weight. So you can say what is the force here. So it is 10 kg weight because you are carrying something. So there is weight, but here it is force. So therefore it is kgf. So this is 10 kg weight or it is 10 kg force. So I think you understand, when you apply force in this to this table etc., to something etc., then it is force. If you are carrying something which is having some weight, is because of earth's attraction down, vertical, downward or upward, in that case you will say weight, kg weight. So otherwise you say kgf. So means these are the relative or the gravitational units of force. Means we, because we feel grams and kilograms, we know grams and kilograms, therefore we do not talk practically in terms of Newton. So for those people who are doing practical work with these forces, they don't go into this Newton etc. or Dyne etc. They directly say grams and kilograms. So this is how you have these units etc. for the force. Now consequences of Newton's second law of motion. So from this formula, so we had a formula. So this formula actually, so we had a formula. We'll again write this formula. F is equal to ma. So we have this formula. F is equal to ma. From this formula you can find that A is equal to ma, F over m. So you can find A is equal to F over m. So F over m. So means you have A is equal to acceleration is equal to force divided by mass. So therefore, for example, why this formula is important now. Although we have not reached Newton's third law, but we know that Earth attracts each and everything towards its center. So Earth attracts each and everything towards its center because action and reaction are equal and opposite. That we'll see in Newton's third law. So whenever there is action, there is a reaction. If someone pulls you, you oppose that person and you start pulling. For example, the weight you were carrying in your hand 10 kg, earth was pulling that and you were also pulling that. You don't feel, but you are pulling that weight because you are carrying. There is no direct fight or you can say quarrel or something like that between earth and you, but you feel the weight because earth is attracting that mass and you are carrying that mass against that force. So against the force of, so you are carrying this 10 kg weight, earth is attracting that in downward, you balance by applying upward. So you carry, so you feel tired, you feel pain maybe. So that is because earth is attracting, you are opposing that by applying this much of force to balance this. So you are applying upward, earth is applying downward. So you cancel that force by applying your body, so force from your body. so from your arm, your muscles, etc. So you feel the tiredness, or you may feel some pain in your arm, etc., because the muscles are doing some work. So therefore, you also do this much of, you can say, you apply this much of force or weight, etc. So earth, when earth attract each and everything, so the reverse is that to balance that we have to attract, or you can say that according to Newton's third law of motion, so we also attract earth. So if earth attract me, I also attract earth. So therefore, uh, equal and opposite force is there. If earth attract me, say by 1000 newtons, say I am 100 kg, so earth will apply a force of 1000 newton, and then I also apply 100 newton. So but acceleration is F divided by m. My m is very small, but earth's m is very large. So therefore, I or we or the things fall on the earth, and earth do not fall on us. So because of this m, if m is very large, acceleration becomes very small. So because it is inversely proportional, a becomes inversely proportional to m. If m becomes large, acceleration becomes small. So this is very important. So from this Newton's second law of motion, we come to know this to this point. So that I have already told you that whenever there is force, there is acceleration. Whenever there is acceleration, there is always force. So this is some basic things related to this Newton's second law of motion. So I think I could have made you understand these things. So thank you very much. So in Punjabi, I will make another video for the same to tell you in Punjabi. Thank you.